This is the chemical bonding notes part 1. In this video we're going to go over periodic table shortcuts, electron dot diagrams, chemical bonds, and then ionic bonds, which is actually a review from the last 9 weeks. So the first thing I want to do, first we have our standards that we're covering. We're covering standard 8.1.4 and 8.1.5, which all talk about how atoms join together forming molecules and how that depends on electron arrangements. So, the periodic table shortcuts. Here we have a picture of our periodic table, and we're going to zoom in and look at our 6 different shortcuts that we have. The first shortcut I want to highlight would be the group number is equal to the number of outer electrons. So all the elements in group 1 will have 1 valence electron. All elements in group 2 will have 2 valence electrons. And over here we've renamed these. Instead of 13 through 18, they're group 3, 4, 5, 6, 7, and 8. And that's how many valence electrons those have. The second shortcut on the periodic table is over here on the left-hand side. The green highlighted area shows that the period is equal to the energy level. So for elements in period 4, they have 4 energy levels. The third shortcut that you need to remember on your periodic table, you should mark all of these on your own, is that the ion charge, which is determined on the electrons gained or lost by an atom, is in pink over the different groups. So group 1, all these elements, to become happy or stable, they're going to lose 1 electron. So if lithium loses 1 electron, it's going to have 3 protons, but only 2 electrons, giving it a +1 charge. Over here on the other hand side, if I have chlorine, chlorine is going to gain 1 electron to be happy, go from 17 to 18, and then it will have 17 protons but 18 electrons, so it would have a -1 charge. All the elements in group 8 over here, those are the noble gases. They don't mix with others. They won't form ions. They don't actually normally work well with others. The next shortcut we have is the metals versus nonmetals. This is slightly simplified, but basically to the left of that stair step, those are metals. To the right of the stair step, those are nonmetals. And then special hydrogen also is a nonmetal as well. That's simplified a little bit, but it'll work for our purposes in class. The other shortcuts we have are APE, A equals P equals E. The atomic number is equal to the number of protons, which is equal to the number of electrons. And so that's what the first one is. That is for a regular neutral atom. And then the second other shortcut, the last shortcut that we have right now, is M minus A equals N. Mass number minus atomic number equals neutrons. If you have those 6 periodic table shortcuts, it will help you understand a whole lot of information much faster. That's why they are shortcuts. Okay, next up, a quick review of electron dot diagrams. These are also known as Lewis symbols at times, named after Gilbert Lewis, who first came up with the idea. Basically what you do is you take your element and you have your element, and you're going to, sorry, I need to get my writing utensil ready. You have your element, and you're going to write down the number of valence electrons outside of it. So the first one we look at is sulfur. Sulfur is in group 16, or group 6, I should say, group 6, so it has 6 valence electrons. So I put on 6 dots around sulfur. Chlorine in group 7 has 7 dots. We try and keep the dots in pairs, top, bottom, left, and right. Hydrogen has 1 dot because it's in group 1. Phosphorus has 5 dots because it's in group 5. And calcium in group 2 has 2 dots. We just combined our periodic table shortcuts with how to easily write down electron dot diagrams. The next thing we're going to look at is, well, here's another picture. Here we have another couple Lewis structures, or electron dot diagrams. All the elements in group 4 have 4 dots, all elements in group 5 have 5 dots, and so on. Chemical bonding. A chemical bond is when you take two or more atoms or ions and they're strongly attached to one another. It's basically just held together by some force that's holding them together, the electrostatic force. Basically, we know that opposites are attracted, so a positive and a negative will pull closer together. An ionic bond is when you have those positive, and each atom has a positive or negative charge associated with it. Chlorine gains an electron, giving it a negative charge, or sodium loses an electron, giving it a positive charge. A covalent bond, on the other hand, is when you have sharing of electrons between two atoms, and the sharing of the electrons is what's holding them together. The other type of bond that we're not going to really spend much time with is the metallic bond. It's found with inside of metals when you have a whole bunch of metals attached, but the electrons can float along. The reason this is a metallic bond is because those electrons, they can flow real easily, which is why we have electric current that can run through metals. Here we have some ionic bonds. We have magnesium oxide, MgO. It's a white powder. Sodium chloride, this is also known as table salt. This is a salt crystal blown up a lot larger. We have nickel 2 oxide, another powder. One of the things you'll notice if you look at the periodic table is that all of these are from one side of the periodic table. Over here we have the left side of the periodic table, and then the second one is from the right side of the periodic table. And what we notice is that it's always a metal connected to a nonmetal. Magnesium with oxygen, sodium and chloride. Covalent bonds, here's some various examples. Sulfur, bromine, sucrose, or sugar. These are different bonds. We have different varieties of how they'll look when they're bonded together. A lot of crystals together. We have some that are just liquids or gases. But what we notice if we look at all the elements and where they're located on the periodic table is that all of these are nonmetals. Nonmetals bonded to nonmetals. And then metallic bonds, they're all metals, which is kind of what you would think if it's a metallic bond. So once again, to summarize that, ionic bonds are between metals and nonmetals. Covalent bonds generally happen between nonmetals and nonmetals. And the metallic bonds form between metals and metals. Once again, as a review, ionic bonding. Ions are charged particles, and atoms can become charged when they gain or lose electrons. If it gains electrons, each electron has a -1 charge to it. So if it's gaining electrons, then it's going to be more negatively charged. If it loses electrons, like the elements on the left-hand side of the periodic table, if it loses electrons, they're going to become more positively charged. Ultimately, oppositely charged particles are attracted to each other. Ions don't have to be one element either. You can have multiple atoms stuck together to form an ion if it has a charge on one end. Here's more of our shortcuts. Elements in periodic table 1 or period 1 are going to have one valence electron and a +1 ion. There's a little gap here which represents the transition metals on your periodic table. There's a gap between group 2 and group 3. That's just shown here so that way you can see that. Gaining and losing. You kind of think of different atoms based on how many electrons they gain or lose. Gainers are elements who will need to gain electrons to become happy, and losers are the ones that will lose them to become happy. So if we look at the elements that are gainers, those are going to be elements in group 5, 6, and 7. And then we'll put a star by 4, because 4 normally will gain as well. Elements that are losers are group 1, 2, and 3. 4 sometimes could lose, but we'll keep that up here because normally we'll think of it as a gainer. So this again is a review. The only thing that's new is the part at the bottom. Gainers and losers bond together to form ionic compounds. If you think back about the periodic table, the ones that are gainers, the ones that gain electrons, most of those, if you look at our shortcut, are all nonmetals. And the ones that are losers are actually metals. +1 ions equally bond with -1 ions. +2 ions equally bond with the -2 ions. And then if you have a +2 ion and a -1 ion, you're going to need 2 of the -1 ions to cancel out the +2 charge to make a compound. Formation of ionic bonds. So here we have sodium and chlorine just hanging out, and if they get close enough, the pull from the nucleus from chlorine is going to pull sodium's electron away from it. Because sodium really wants to get rid of that electron, chlorine really would like to take that electron. So they switch, and now I have a sodium ion and a chloride ion. The sodium ion has a plus charge because it had 11 protons and 11 electrons, but it lost one, so it now only has 10. Chlorine gained an electron, so it has a -1 charge. This has a +1 charge, this has a -1 charge. So therefore, they're going to be attracted towards each other, and they're going to form sodium chloride, table salt. Here we're going to have a couple more compounds. On these, we're going to go ahead and write out how much, write out the symbols or the formulas for them. First, we got to figure out the charge on them. Calcium is in group 2, so it has a +2 charge. Rubidium in group 1 has a +1 charge. Boron is in group 3, so it has a +3 charge. Chlorine, on the other hand, is a -1 charge because it's in group 7. And oxygen has a -2 charge because it's in group 2. So I have a +2 and a -1. So I'm going to write Ca. I'm going to change colors so that you can see a little bit better. It's going to be calcium CaCl2 because I need 2 of the chlorine atoms to cancel that one. I need 1 Ca and 1 O, and they will cancel each other out. Rubidium, I need 1 rubidium and 1 chlorine, and they cancel each other out, +1, -1. I need 2 rubidium to cancel out the -2 charge from oxygen. And then on my final example, I have boron, chlorine. I need 3 chlorine to cancel out the +3 charge. The last one, boron, I need 2 of them to give me a +6. And then I need 3 oxygens to give me a -6. So +6, -6, they cancel each other out. So that's a quick review of ionic compounds. In the next video, we're going to learn more about how covalent bonds work. How do you read them, and how do you write them? Hopefully you've learned. If you are confused about anything, make sure you rewatch and rewind this video. Thanks. Have a great day.